In this video, we're going to continue with our 5.2 lesson of verifying trigonometric identities. And I'm going to do a whole bunch of examples. So, feel free to come and go whenever you need to. Some of the examples are way more complicated than others. So when you get to something that you're stuck in, maybe find an example that I'm doing in one of my videos and watch that example. Okay, so in this example, we need to prove that 1 over 1 minus sine of x plus 1 over 1 plus sine of x equals 2 secant squared x. And one of the hints that they gave you on page, I think it was 197, they said to start with the more complicated side and turn it into the easier side. So I think most of us agree that fractions seem to be a little bit more complicated. So I'm going to start with the side that has the fraction, and I'm only going to work one side. And I notice right away that I have a binomial in my denominator, and whenever I see a binomial in my denominator, I automatically think of multiplying by the conjugate. Okay, so I'm going to multiply both of these by the conjugate of the denominator. Okay, so that is 1 plus sine of x. And remember, I have to multiply by the number 1. I can't just multiply by the conjugate in the denominator, or else I change the value of the fraction. So the conjugate of 1 plus sine of x is 1 minus sine x over 1 minus sine x. Sometimes we do these things and it doesn't help us at all. So the other thing I want you to keep in mind is that secant squared of x is really 2 over cosine squared of x. All right, so keep that in mind while we're working through this. I'm going to just keep that up here in green. I think I'll keep it up there in green just as a hint so that we know what we're really trying to get to. All right, so when I do this, I should end up with a common denominator. Right, when I multiply, I'm going to get 1 plus sine of x minus sine of x, so they'll reduce out, minus sine squared x plus 1 minus sine of x over 1 minus sine squared x. And in our Pythagorean theorems, right, in our Pythagorean identities, we have sine squared of x plus cosine squared x equals 1. If I subtract sine from both sides, 1 minus sine squared x is just cosine squared x. So that looks really good. So I'm going to replace 1 minus sine of x with cosine squared x. Let me erase that because we're not really supposed to have anything on that side. All right, so now what are we going to do? I say that we combine these into one fraction. So we get 1 plus sine x plus 1 minus sine x over cosine squared x. We'll extend this. And you'll notice our signs reduce out. We get 2 over the cosine squared x, which equals 2 secant squared x. All right, so we did prove this, right? By keeping this in mind, when I got to a certain stage, I knew I did it correctly. Okay, don't forget to draw your arrow down. All right, so how are we going to do this? Well, I'm not really quite sure, but maybe I think the left side looks a little bit more complicated than the right side. So one of the things we could do is we could look at changing everything to sine and cosine and see if that helps. Let's try that. Okay, so cosecant is 1 over sine. Cotangent is cosine over sine. In my denominator, I get sine over cosine plus sine over, let's just say 1. Okay, all right, so in the numerator it looks pretty easy. Looks like I could just add the two, 1 plus cosine over sine of alpha, but in the denominator they don't have the same denominator. So maybe what we could do is we could get rid of our complex fraction and multiply everything by sine of theta cosine of theta over sine of theta cosine of theta, just to get rid of our complex fraction. So remember, we're going to distribute this across both terms, and our sine will cancel out when we distribute this. So we're left with cosine of theta. Here our sine reduces out. We're left with cosine squared theta. Here, when we multiply, our cosines cancel out, so we're left with sine squared theta. And here we have sine squared theta cosine of theta. All right, so I know that here I could, let's see if factoring does anything, because I have something I could factor out of the numerator, something I could factor out of the denominator. Let's see if that even helps. So if I factor out a cosine of theta, I get 1 plus cosine of theta. If I factor out a sine of theta, or sine squared theta, I get 1 plus cosine of theta. Oh, that worked out well, because now my 1 plus cosine of theta reduces out, and I'm left with cosine of theta over, and I'm going to split this up, sine of theta, sine of theta. And what do I know about this? I'm going to put a multiply by 1 here. I'm going to circle those two because I believe that gives us our answer. We need cotangent times cosecant. Well, cosine of theta over sine of theta is cotangent of theta, and 1 over sine of theta is cosecant of theta. All right, so we ended up proving it. I was kind of unsure when I started this proof as to how to work through it, but just by analyzing the left-hand side and saying, well, I didn't know what to do with this. This didn't look like anything I'd ever seen. So I thought, well, one of the hints they have on page 197 is to change everything into sine and cosine. And then I noticed from algebra that this is a complex fraction, we could get rid of it. And then also from algebra I noticed, well, maybe we could factor something out. And so I just tried stuff to see if I could eventually get there, and we did. Okay, well, this one's completely obvious which side we should start on. The left-hand side is way more complicated than the right-hand side. So I think what I'm going to do is I'm going to start by factoring. Okay, so this is in the form of a squared minus b squared, right? A squared minus b squared. And in this case, a squared is sine squared minus b is going to be cosine squared alpha squared. Okay, so that's just a helpful hint for the numerator. So let's go ahead and factor that into a plus b, a minus b. So I get sine squared alpha plus cosine squared alpha times sine squared alpha minus cosine squared alpha. And before I factor the denominator, I just want to point out that sine squared alpha minus cosine squared alpha, that could reduce out if we don't factor it. So I'm just going to leave it unfactored and see if it reducing out helps it all. So I'm going to reduce this to sine squared alpha plus cosine squared alpha. And now you can see this is a Pythagorean identity. Sine squared alpha plus cosine squared alpha equals 1. I know this side equals 1. A nice Pythagorean identity. Awesome. So we are done. So what looked really complicated ended up not being complicated. We probably have time for one more, and then we are going to, I'll start another video. So which side looks a little bit more complicated? Well, to be honest, I'm not really sure which looks a little bit more complicated. But I could, let's see. I could change everything on the right-hand side. Okay, let's see what happens if I don't know. What could I do? Let's go ahead and change everything on the right-hand side into sine and cosine, because I really don't know what to do here. So, because this is not a Pythagorean, I mean it is, like if I did sine, squared theta plus cosine squared theta equals 1, I could subtract the 1 to this side and subtract the sine to the other side. I could do that. I could replace cosine squared alpha minus 1 with minus sine squared alpha. I just don't know what that would give me. So let's go ahead and just change everything to sine and cosine and see what happens. Hopefully that'll work out. If it doesn't work out, I'll just put this in the next video doing it a different way. So this is sine squared alpha over cosine squared alpha plus cosine squared alpha minus 1. All right, so maybe I could change, or maybe I could just put everything over a common denominator. Let's do that. Let's continue this and put everything over a common denominator. That makes this to the power of 4 minus cosine squared alpha over cosine squared alpha. And now I could say that sine squared is 1 minus cosine squared, because that's an alternative form of my Pythagorean identity. 1 minus cosine squared alpha over cosine squared alpha cosine to the 4th alpha over cosine squared alpha minus cosine squared alpha over cosine squared alpha. And now when I join everything into one fraction, minus cosine squared alpha all over cosine squared alpha, I see that I get, let's see, 1 minus 2 cosine squared alpha plus cosine to the 4th alpha all over cosine squared alpha. And I know that I could switch terms around and factor. So I'm actually going to switch my terms around. I don't know whether I should or shouldn't. I don't know. I'm just going to switch them around, and then that does factor. That's a nice trinomial, and it factors into cosine squared alpha minus 1 squared. And now I look at that and go, cosine squared alpha is sine squared alpha. Cosine squared alpha minus 1 is sine squared alpha minus 1. And I think we're getting really close to the end. So I'm going to split this up and say sine squared alpha times sine squared alpha over cosine squared alpha. This turns into tangent squared alpha, and I think